Hi, I'm going to show you how to make a simple Flappy Bird game using really simple stuff. So this Espruino Pico here and a LCD display that I got off eBay for around $2. So by Flappy Bird game I mean something like this, where you basically have this little bird and you have to click a certain amount to kind of get it through all the different holes. And you know, if you hit one of the sides, then you lose. So first step is we're going to look up this particular display. If you look this up on Espruino.com, you'll find this stuff, a load of examples, and we're interested in using it with the Pico. And this is a really good one to look at because it just shows you how to do really simple animations on it. So if we follow what this is saying to do about wiring it up, I'm basically going to take a bit of breadboard here, put a Espruino Pico in, and then I'm going to take the display and put it in just basically one thing to the right. So it's completely aligned with the right hand side of the Pico. So if I whack that in there and I plug it into USB, when you plug it in you need to make sure that the white bit of the USB connector is facing the gold of the USB of the Pico here, and you'll see it flash. So at the moment nothing's happening, but we'll just we'll go right the way down to the end and get like the nice animation that this has here. Take this, copy and paste it in, upload, and now as the instructions say, you just need to call on init here to make it run. So we could do that here, or in fact we could stick it down here just for testing. This is looking kind of dark here because we're looking at it from an angle, so we can quite happily go and adjust the contrast of it and try some different things. So if I try 0.3, whoa, that's way too bright. This is a bit better. Yeah, that's about fine. Okay, so now we've got that nice. We'll take that and we'll copy it into the initialization code that's right about here. So now I've got all this. We don't really care about the text that we're doing here, so we'll just put all that out. So at the moment, if I upload this, it won't do anything at all. It will it'll basically just come up and show you a blank screen. So now we want to be able to define our bird. So let's get rid of pause because we won't need them anyway, and we'll have bird y. And because we want the bird to have a velocity as well, so that it's affected by gravity, we'll define bird vy. So first off, I guess we probably want to start the bird off in the middle of our screen. This screen is 48 pixels high, but we want halfway down it, so we'll do that. And now let's try and do some animation. So first off, we want the velocity of the bird to basically keep going up by a certain amount for gravity, and we'll say that we now want to control the bird's direction and just add the velocity to it. So now we'll draw a simple rectangle here. So we'll draw it right on the left hand side of the screen at bird y -4 maybe. Let's make it -3, go 6 along, and then bird y +3. So now if I upload this, we'll see that thing just really quickly fall off the screen. And to be honest, that was a bit quick. So let's make gravity a little bit less. Still a bit too much, I think. Okay, so you know we can fiddle with that and make it better. But now we want to care about actually making the bird flap, and we can use this little button here. We'll look at how to add a slightly bigger button later, but for now we'll just use that. So that's called button, btn. So if we say button.read, it comes out as false, and if we press that, it'll come out as true. So really what we care about is we don't want to keep going up. We only want to go up for a little bit when the button's pressed. So if we add a variable here called was pressed, and then we say something like, we'll add button state, where we'll read the value of the button, and then we'll say if button state and it wasn't pressed, then we'll actually like give the bird a really big boost up. That's probably way too much, but we'll see. Okay, and then we set was pressed to button state here. So now, hopefully, if I, whoops, it's a bit quick. Okay, so now if I upload, we do this, and now you can see it jumps it up quite nicely. So you know, that's kind of too much really. Let's try and move that back down. Let's make that 1. See what happens. Whoa, nowhere near enough. 2. Try again. And you know, that's actually probably okay. In fact, the thing that's probably causing this problem here is that there's no friction. You know, and usually there'd be air resistance. So to do friction, we literally just multiply it by a certain value. So let's make that like, let's make it 0.8 and have loads of friction. So now it won't ever go down too fast, because effectively air resistance is stopping the bird dropping very quickly. And you know, I think that's probably good enough for now. So the next step is to worry about what we'll do for making making the little barriers that come towards this. So if we create an array called barriers, and we'll create a function called new barrier, which will just create a new block for us. So we'll say barriers.push, which will add a new item onto the end of the array. And all we really care about, I guess, we want to let's allow us to actually give it an x coordinate. And let's make the y coordinate random. Random is a value between 0 and 1. As we say, we've got 48 pixels. So maybe we'll leave 10 pixels at the top, 10 at the bottom, and so that means that we need 28 pixels in the middle. So now it's going to go either 10 from the top, 10 from the bottom, or somewhere in between. And for the moment, we'll actually, let's call that gap. This will be the gap between the top and the bottom, and we'll leave this fixed at like, maybe 15 or something. Actually, we'll make gap actually double the value that's in here. So if we want to find the bottom of it, we do y minus gap. If we want to find the top, we do y plus gap. So now I've got this. Let's just add a new barrier here. In fact, let's add a few so that we can see what's going on. This has got 84 pixels going along the width of it. So we've got these barriers, but we can't see them yet. So we've got the birds that we're drawing here. If I could spell, and then let's draw some barriers. So we'll just say barriers at 4 each, and then call the function with the barrier as an argument. And now we just want to look at drawing some of these. So let's do, let's go for really simple squares at the moment. So actually, let's shorten that and call it b. So we'll say b.x. Let's have x1 and x2 so that we know the beginning and end of the barrier. So we'll just make it like maybe 10 in total wide. So we'll draw that between b1, say x1 and x2, and we'll go for, first we'll draw the top, So we'll actually go slightly off the top of the screen so we don't get the top part of the line. And then we'll go for the barrier, as we said, minus barrier.gap. And then we'll draw the bottom in here as well. So this time we go b.y plus b.gap. And then we'll just go for whatever the height of the display is. Well, we know it's 48, but this makes it a bit more readable. So if I do this now, whoops, I seem to have a mistake. And it's basically because I can't spell. So let's try this. So now we've got these barriers. I've done something wrong here because, yep, I was looking in G for the gap. Let's try that again. Okay, so now we've got these. This is all looking quite good. For some reason, the value of Y looks to be very, very similar. And we can actually just dump barriers on the console and see why it's similar. And it does look kind of weird. Because, yeah, if we look at math.random now, we're still getting loads of different values. And as you say, it's random. So it could just be whatever. If I do it now, yeah, it's much better. And if I press the button, hopefully will come up. So I guess we probably want to leave a bit of room initially. Maybe we'll only have the first two barriers in here. So we'll just remove that one here, there. And then we also want to look at moving the barriers towards the bird. So this is pretty simple. We have x1 and x2. Let's just move them back. Okay. So if we do this, hopefully we'll start to see the barriers moving. And that's pretty quick now. Maybe that's a bit too quick. I don't know. Let's make them a bit slower. And in fact, let's just define a variable called speed so that we can change this. And perhaps we'll actually make the speed get faster as you go to higher levels. So okay, let's go for half that speed and upload again. We've got this. And we're already looking quite promising. So the problem we have is that these barriers are going off the screen now, and yet they're still there. So if we actually look at this, these values are getting negative really quickly. So what we want to do is we want to check to see if a barrier is off the screen completely, and if it is, remove it. We know x2 is going to be the highest value in here. So the easiest thing to do is, we know the barriers are in order, so we'll say while barriers.length to make sure we've still got some barriers, and barriers brackets 0 to get the very first barrier, .x2 is less than 0. Let's just do less than or equal to 0, just to be sure, and then we'll say barriers.shift. So barriers.shift will take the barriers off the beginning of the array. So if we have a look here, and we'll check, and hopefully as barriers disappear, they will slowly disappear from our array. And now we want to look at kind of adding more barriers. To be honest, the easiest thing to do here is to, for now, just to add another barrier in. So let's add a new barrier actually at the end of the screen. So we've got this. Let's move this over so we can see it a little bit better. And now we're starting to get barriers constantly scrolling onto the screen. So this is kind of nice. Although we do have a bit of a gap between them, mainly because of the way we've arranged this. But if I were to change this to 42 and 84, so now they'll be equally spaced, we should start to see these things working a bit better. Now we need to add a bit more of a game to it. So let's create some functions called maybe game start and game stop, which we'll use later on. What we care about is now checking whether the bird has any problems. So we won't care if it's gone off the top of the screen. Off the top of the screen happens when the value is less than 0, because all the values run down the screen. So once we've changed the value for the bird, we'll say if bird y is greater than the height of the screen, then we'll just end the game. In the same way, we can check the bird against the barriers. So first, I guess, we want to check the bird against the x and y values. We'll kind of on the side of caution, and although we're drawing a cube for the bird, we'll just go by kind of the middle position of the bird, and it'll give you kind of, you know, a bit of safety if you get something a little bit wrong. So we'll say well, in fact, we know the bird value because the bird's right at the start of the screen. So here we're drawing it up to 6. So let's say if b.x1 is less than 6, and in fact that's all we really have to worry about, because as soon as it gets right the way off, as soon as x2 is off the screen, the whole barrier will be removed anyway. So check that, and then we say, and we want the top and bottom of the barrier. Let's define some variables for those. So top of the barrier was this, and the bottom of the barrier was this. So now we say bird y, I suppose we're saying first off, is the bird going to run into the top? And we know the bird's kind of these 3 pixels, so we'll say bird y minus 3 is greater than top, or so that's running off the top, and now we'll check the bottom. Bird y plus 3 is greater than the bottom. Okay, so now nothing's actually going to happen here. You know, we're calling this function, but it's not doing anything. So let's create a variable called running, maybe. And we'll start the game running properly normally. We clear it here, but we'll say if we're not running, then we'll just like draw game over or something. And we'll try and kind of put that in the middle of the screen. That'll probably be wrong, but it doesn't really matter. So do that to send it to the screen, and then we return, because we don't want to do any of this other stuff. So game stop, running is false. And game start, which we're not calling yet, we'll say running equals true. In fact, we'll go and look at this later, but let's send this over now. And hopefully, whoop, game over, because I hit the end. I'll see if I can do a little bit better. Got that. And obviously if I hit the top, then game over again. So while I'm here, I'll just shift that over a little bit. But we want some way to start the game. Now, if I said game start, we'll probably see it flash up and then stop almost immediately. And the reason it's doing this is that we haven't actually reset the game at all. It's still exactly where it was where there was the problem, so it's just going to hit the barrier again. Instead, this stuff which we did once, we'll now do right at the start of the game. And we'll kind of reset the barriers here maybe. And oh yeah, we had the bird position and velocity, which let's grab those. So let's just define these variables up here, but to make life simpler, we won't give them values. And we'll make it not running at the start. So set the barriers up, set the bird position up here. And now, yeah, maybe right at the bottom, we'll just do game start. Hey, actually, why not do it when we've got the got all this set up? So set interval, draw, and then game start. Yes, let's whack that up there. We'll just get rid of that comment for now. Okay, so now, hopefully it'll start running. Whoop. It'll work, yep. So now if I kind of run into a wall here, we'll go game over. We don't have a way to start it yet, but if I type game start in the console, hopefully we can start off again, and we're good. So yeah, this is, you know, looking more like a promising game now. All we need to do is to get it to start again, and easiest way to do that is in here where we're doing it. We'll let's just move the button checking right up to the top, and here we'll say if the button is pressed, and someone might have been pressing the button before, and we don't want to restart immediately. So let's go for that, and we'll just say running equals, no, let's do game start. So if I leave this now, die, if I press the button, we'll start again. And finally, we'll add a few more little things to it. So maybe we'll add the score, and the score will just be the number of frames that of the game that the player managed to go through without hitting anything. That's nice and easy. Let's add the score up here. As before, for a new game, we'll make the score 0. And basically, yeah, just while we're running, just stick it in here, add one more to the score, and when it ends, we'll try and write the score. So let's stick the score, let's stick it over the left-hand side. Yeah, and maybe do that on a new line as well. Oops, wrong one. Okay. So now we've got game over, the score, and the actual score written underneath it. So if I just let this die, we'll see there's the score there. And if I run it again, and then I try and get through another one, we'll hopefully see there's a slightly higher score. Brilliant. So, you know, we've now got basically a completely done game. The one thing we might want to do is to make the little blocks look a little bit more interesting. And that's easy enough to do. So let's look at making the tops of these a little bit wider maybe. So let's push them out by 2 pixels on either side. We had top here. Actually, rather than making the main bits wider, let's make the little bits at the top and bottom thinner. That's a lot easier to do. So let's make that thinner, and we'll copy that, and we'll make those thinner as well. And all we need to do is make these ones go up almost to the top, and then these ones at the very top. So let's go for 5 pixels, let's say, and we'll put 5 in there as well. This one, top -5. This one should go btop to btop -5, and actually I messed up here, I think. No, that's good. So let's try that and see how that looks. Yeah, okay, and now it's looking, you know, it's looking a lot more like a Flappy Bird game. About the only thing we might want to do is to have a go at a Flappy Bird icon. I've done something wrong there, haven't I? What have I done? See if we can start it. Okay, for some reason the button wasn't working there, but looks to be back now. Okay, just a quick addition to this. The reason it wasn't working is because I was setting the state of was pressed here. And obviously when the game's not running, if you finished the game while it was running, then it wouldn't be updated. So let's just stick that in there. So yeah, all we really need is the Flappy Bird itself. Now if you look on the Espruino website for graphics, there's actually a way to make a bitmap in here. So so this is like a really simple way of doing it, but this one works out really well because it's 8 by 8 pixels. You can use bytes for everything, and you can just draw it as ones and noughts. So if I copy this example, and let's just whack it in here, call it bird image. At the moment it's kind of a smiley face, but we'll leave it at that. So where we were drawing our rectangle, let's get rid of that, and let's say g.draw image, bird image, and then we've got the x and y, which we'll leave x the same, and we'll only use up 6 pixels of our 8 pixels. We'll leave the rest unfilled, and then we'll set it to bird y -4. Because it's 8 pixels, we might as well keep it nice and central. So if I do this now, we should see a little smiley face. Obviously not our bird, but now it's nice and easy to do. So let's go for kind of a round birdish sort of shape. I'm not the greatest pixel artist, but I don't know, something like that's probably going to work okay. So yeah, and now we have, whoops, we have our fun little bird, and that's our Flappy Bird game. You know, it only took a few minutes to do, and it's only just over 100 lines of code. So if we want to take this and actually turn it into like a fully fledged standalone game now, basically all we do is we'll remove the on init from here, upload it, and type save. And now it'll come on and it'll work fine. First time everything will go, but if I unplug this from the USB and plug it back in, so now it will only be getting power from the computer. Do this and it's back immediately. So dead easy to actually now put this in a box as it is without doing any soldering, but you can make a really nice little compact unit with it. Okay, so now I'm going to solder everything together. I've got the little Espruino Pico here, the one without pins, and a display with pins, and I have the little power connector there. So first off we'll fit the power connector, and the power connector, it just literally goes on here like this. Now it can be a bit tricky to get it all connected first, but what I'll do is put a little bit of solder just on that connector there, and we'll just make sure that that all gets nicely tinned. And now we'll just basically use that to fit the connector on. So we'll just heat it up and move the connector into position, and that's about right actually. You could fiddle around and do it a bit more nicely, but you know, it's good enough for this. So we'll heat that one up, and then we'll solder those two on as well. So let's go back to how we had this wired up. We had it like this before. So we basically just want to redo that. So we'll take that did go like that, and we'll just stick it around on here. You can see it sits quite nicely on the battery connector here. So all I have to do is put a little bit of solder on here, and then I'll just kind kind of move this around with my finger to make sure it's kind of all nice and straight and sitting correctly. And yeah, here we go. I just programmed it in exactly the same way as the other one. And let's just, we press the button on the back, and there's our little Flappy Bird. Okay, so what I've got here is an old bit of window frame that's just hardwood, and I'm basically just going to cut a box out of solid wood for it. Okay, so my battery went flat, but basically I cut a hole in here which will go along with the USB connector, so we can still program it and do other stuff if we want. Nice thing about that is that I can actually then get a belt sander in there and can finish the edges off much better and leave a bit more room. So yeah, the next step is to get this all set up. So that's going to go in there like that, and then this will sit on there like that. So all I need to worry about now is basically gluing up this edge, and I'm actually just going to super glue this in at the corners as well. So it sits relatively flat. That's all good. So yeah, nice and easy. This is mitre fast. It's cyanoacrylate, so it's like a super glue kind of thing. But it's just really cool because you can basically apply it, and then you can use a kicker spray to make it go off nice and quick. So whack that on, put that on there, and the way I'm doing this, I'm not really going to bother about getting it all nicely aligned. I'm just going to go and sand it afterwards. So that all looks good. That's done. Let's get some kicker spray on it. And while that's going, I'll just put a little blob of glue on here which will hold that in, and the same up there. And that will probably do us. That's our nice little thing. What I'm going to do is stick this button in there in the middle so that we can now use that to do our bird. And again, I will just stick that in using the mitre fast glue. Okay, so I've now got the little button glued in here, and it's all nicely sorted in the back. Got this held in. All I'm going to do now is put the back on, give it a bit of a sand down and kind of smooth around the edges and make it look a bit nicer. Okay, so now I've just got to wire the button up. When you press one of these buttons, these two pins or these two pins get shorted. So basically you just need to attach two wires, one to there, and then bring it to the board. And on the board we've got power here. This one is a 3.3 volt line, and then any of these can be I/O. So I'm just going to connect in one to there, third in from the end, and one to fourth in from the end. Okay, so now all that's left is to change the software. The pin we've connected that black one to is B3. So basically all we need to do is to change wherever we use button, change it to use B3, and set the pin mode of B3 to input pull down, because effectively normally you'd have a pull down resistor, but we can do it in the chip and avoid ourselves a little bit of wiring. So this is all wired up now. I've put the new software on it. I've got the battery in there. It can be a little bit fiddly to get it in the back, but with a bit of poking around it's easy to get in. And this is it. So we have a little button, which I taken one of these, which comes with the buttons and you can clip over the top. And I've had to take the little rim off just to give it enough space, because usually these things are meant for very thin metal cases, and I've got quite a thick wood one here. So this is it. I have added a little back plate to it now. I've chamfered the edges of it and I've held it on with an elastic band, which actually does quite a good job of holding it shut. So yeah, it's a nice, fun, easy to use Flappy Bird game that you can really easily customise. So thanks for watching, hope you enjoyed this. If you want to see more things like this, please subscribe. If you really like what I'm doing, please check out the Patreon page, because hopefully that'll help me to do more things like this as time goes on. Thanks for watching.